Okay, here we are again with this unconventional way to approach signal processing. As I already commented, um, the way that I'm approaching this topic is not the conventional way to approach. Um, if you saw on online courses on this topic of signal processing, they already start discussing about trigonometric functions and with the most famous one, which is the sinusoidal function. So I already comment this with you. Uh, this is more, this is the most conventional way to approach signal processing, um, and they already start uh, doing a discretization of this function. And I said that right here, my goal is to build a intuition of functions, and we already has discussed it about the square function, the cube function, the x squared, x cubed, and also 1 over x. And right here we start discussing about the concepts of continuity of a function. We also point something, we point things like symmetrically functions, when they are symmetrically, how can we mirror this function? Not exactly how can we mirror, or how can we know when they are symmetrically proving, doing the proof algebraically. Those things I'm not approaching right here. My goal is just to build an intuition of functions, so just doing a scratch by hand of this function, just attributing values for x and plotting, doing a scratch, a sketch by hand, just trying to draw to illustrate this function. And just by looking at the function, we can say if it is symmetrically, if we can mirror, and things like if it is continuous, if diverging or not, if it's converging. But sometimes just looking at the function, the face of it, um, we cannot tell such a things. We need to do a algebraically manipulation and try to prove this algebraically. Sometimes this is necessarily. Okay, and again, this is not a conventional way to approach this topic. But right here, you can understand functions. And also, my goal is to plot these functions in Octave. And again, if you are interested in signal processing, this area, this field, the way that today's days they are being approached is with the theory of signal processing. So you need to be good at math and functions, and these functions, they are made of sinus, they are functions. And also on today's days, in order to use this theory to solve real world problems, we approach this on computer using tools for numeric computation, just like we are doing right here with Octave. Okay, so without wasting time, let's continue with our studying about functions. And like I'm commenting further after uh, we build this intuition of functions, and you will see what, because on the real world signals they are not always well behaved. um, it's most common to start with the signal function. So we start with the signal function, and further we can um, discuss. Of course, we will discuss about this function, and just doing comments. Um, we also got this square wave. So on the real world, we got signals like the sound. So we have audio files, and so right here it can be a audio file, and square waves, they are a sum of signals and of sine a cosine signals, something like that. I don't know exactly. And they are not always well behaved. We will see we very often, and actually on the real world signals, they are more this way. They are not uniform and well behaved. And right here we can have, I don't know, a exponential, and so t over 2, and right here square of t. And also we are, when discussing about signal processing, we are also interested on the power of the signal. So in order to measure the power of the signal, we will take its integral. So it's something like that. So you can imagine right now why we are just taking our time and starting slowly. Again, I'm just trying to build with you intuition of functions, and we are starting with the most simple ones. And instead of actually in order to adapt these functions to a real world problem, so you need to know, if you find a real world problem in which you can do this approaching with some of these functions, like instead of do f of x, we can change this for f of t. So we are doing a adaptation of these problems. Okay, so let's continuing, and on this video we will do a sketch of the function x, square root of x. So as we are doing, we will just pass values to this function, and the most values that we passed, more we are covering this function, and better we can represent this function visually. So we can pass 0, 1 over 4, 1, and 4. Just 4 values. And f of x, which is equal y. And we cannot pass negative values because we cannot take the square root of negative values. So square root of 0 is 0. The square root of 1 over 4 is equal 1 over 2. Square root of 1 is equal 1, and the square root of 4 is equal to 2. Very simple. And now let's try to draw this graphic. Do a scratch by hand. Just pencil and paper. So the x-axis and f of x. And now passing the values for the x's. We got 0, we got 1 over 2, we got 1, we got 1 over 4, 1, and 4. And right here we got 1 over 2, we got 1, and 2. Okay, so now we just need to connect these points. So for x equal 1 over 4, we got 1 over 2. For x equal 1, we got 1. And for x equal 4, we got 2. Okay. Now I just need to draw this function, something like that. Very simple. Okay, now the most important part, which is plot this on Octave. So like we were doing, first of all, we need to specify the x-axis, passing the limit of this axis. So we just need to attribute variables. We need to name variables and attribute to these variables the limits of this axis. So for the x-axis, we got the limit 0, which is the minimum limit, and the maximum limit is 4. So let's name a variable of x-min and pass to this variable x-min the minimum value of the x-axis, which is 0. And now we'll name let's name a variable as x-max and pass to this variable the maximum limit of the x-axis, which is 4. Now remember that we use the line space function to draw the x-axis. So we will attribute now a x variable and pass to this variable this function linspace. So linspace will draw the x-axis, and we need to pass to this function linspace the arguments, which is the limits. So x-min, x-max, and also we need to attribute the number of points that which is kind of which is is exactly the number of points that we are drawing on the x-axis, and is the precision how the function will looks like, and the most point that we passed most precisely this function will looks like. So just 100 points is already enough. Now let's build our function itself. Y is equal, and right here to take a square root we use SQ or T, which is the abbreviation of square root. So square root of x. So we have just built our function, and again we can run it, but we need to ask to the Octave to plot with the command plot. So plot x and y. So we are plotting the axis, and there we go. We did it. So as you can see, we have just plotted the function square root of x, and we can even try to comment something about this function. I don't know, we can say that that is a continuous function. We don't have any point in which the function is discontinued. What else? It's very intuitive. If we keep passing values to x, and the most greater these values are, so as x is increasing, so the function it will also increasing. So we can say, and again sometimes we need to prove this algebraically to say something. So we can take its limit. So as x approaches to infinite, right here, the function will also grows to the infinite, increase to the infinite. So we can say that this function is converging. For real real values. What else we can say about this function? Um, I don't know. I think I have said all that I have to say. Okay, that's it. We are not doing anything math or programmation. This algorithm is very simple, very easy. Um, and after we pass to these basic functions, we can we can start with trigonometric functions, sine, cosine, exponentials, and also you will see that uh, real-world signals for uh, for these signals we need to sometimes, the most of the time, use imaginary numbers and complex numbers. So we got the real and the imaginary part, so complex numbers, sorry. So after this we will see trigonometric functions and complex numbers, and most of the time working with the Octave and how to work with Octave and program uh, with Octave, how to build these algorithms. And that's it. For now it's all. Hope you like, hope you enjoy it. Thank you.